If I remember correctly, the question is that does this effectively deal with like the SMM rootkits that came out in FRAC and like the last issue or the one before that? If I remember correctly, they're trying to actually take advantage of chipset stuff where they use the IO instructions in order to actually set up values inside the chipset. Because you can intercept those instructions by defining conditions inside the virtual machine control block, you could essentially mitigate some of that, but you have to, again, build logic around it. I'd have to look at those papers again, but I think my initial reaction is yes, I think this would take care of it. All right. There we go. All right. Anyone else?
How could this be used for evil?
How could this be used for evil? I don't really have a good use for that. What would it take to boot MS-DOS? Inside of a virtual machine or inside an SMM? I would have to look at it, but basically you would have it is 16-bit mode code. Yeah, you can do software interrupts from SMM. All right. Okay. The performance, because this is all happening in hardware for the most part. All right. Yeah, sorry. The question is, what is the performance impact of all the context switching back and forth? The performance impact for a lot of the sort of hardware accelerated stuff, like in the guest, not so much. When we switch out and we end up doing system management mode inside of the virtual machine, because it's a shadow page table and we have to emulate the paging and everything else in software in order to control it, there is a distinct increase in overhead. I haven't benchmarked it to really see how much of an overhead increase it is, but given that shadow paging and software paging is one of the biggest performance bottlenecks for virtual machines, it's certainly not zero. It's probably somewhat significant.
You say something about the segmentation in SMM mode. You said that effectively it has access to the full 4 gigs of RAM, like it's 16-bit mode. So how does the segmentation actually run? You said it expanded the segment descriptor or something like that?
Yeah, the segment descriptors are extended all the way to 4 gigs as part of SMM. So the question was, it's 16-bit mode, and how does it actually get access to all of system RAM? Now, by default, it won't actually be able to address more than a meg, just because it's in 16-bit mode. However, you have the 32-bit override, or you have the override prefixes in x86 that'll let you do 32-bit instructions inside of SMM. So you can actually get access to more. The other thing you can do too is you're starting out in real mode, or real mode-like operating mode, and you can in fact bootstrap yourself into long mode or protected mode from there. Anyone else? Oh, over there.
Does this offer any protection if you have a malicious BIOS?
Like I said, up to a point. The point is that provided that the virtual machine monitor is able to get control of SM lock, meaning that SM lock is able to be set to 0, where you use like SM key to set that, then you can use the virtual machine monitor and SKinit after the fact to bootstrap your way through. But if the attacker, in fact, just says, no, SM lock is set, there is no password, then you really can't do anything to stop like system management mode at that point, because you lose all the interceptions. Okay.
Where can we find my motherboards protected using this kind of method?
Okay, the question was, where can we find motherboards that would be protected using this method? It's not really a question of the motherboard as much as it's a question of the BIOS. So which BIOSes are actually set up with keys and whatnot to do this. Off the top of my hand, I don't know. I was using core boot for most of my experimentation, so I was controlling the BIOS just to see how the features actually worked. But it would be something like worth looking into. All right. If anybody's actually interested in seeing the code and other stuff afterwards, I'll be in the bar. I can't distribute it because there's some licensing stuff with CMU, the way they put up MAVMM. So as soon as I work that out, hopefully I'll be able to clean up the code and patch it and release it. But if people are interested, I'll be downstairs in Harry's Pub, and I can show you what I did. All right, thanks.
Jamie's downstairs.
Okay.
You lost that.
Thanks.
Somebody returned it back to registration, so I brought it up.
That's awesome.